The question is asked in the UGC Net Economics paper of June 2024. This is the second part. The question is, a firm's production function is being given as says that Q is equal to 12 minus 1 upon L into K times L plus K. L and K denotes the units of labor and capital employed. Q is the total output. The prices of labor, capital and output are being given as says $1, $4 and $9 respectively. We have to find out the maximum profit. Okay, so let's write the given production function, that is Q. Q is equal to 1 upon Lk times L plus K. Okay, this is the production function. Also we are being told that the price of labor, let's denote it by P subscript L, it is being given as $1. Price of capital, let's denote it by P subscript K, it is being given as $4. And price of output, let's denote it by only P, that is P is the price of the output, that is the price of Q, which is being given as $9. We are supposed to find out the maximum profit. Okay, so first thing will be, we will form the profit equation. What is the profit function of a firm? So we know profit for the firm will be equal to the total revenue minus the total cost. Okay, now let us see what is the total cost. So what will be the total cost for this firm? Total cost will be equal to the price of labor times units of labor employed plus price of capital times units of capital employed. This will be the total cost for the firm. What about total revenue? Total revenue will be equal to price into output. So can I write profit will be equal to total revenue is P into Q minus total cost is this function, that is price of labor times units of labor employed minus, so here we have minus, it will become minus, then we have minus price of capital times units of capital employed. Okay, so let me rub this out here. Now we are being told that the price of labor is 1, price of capital is 4 and price of output is 9. So can I write profit will be equal to, so in place of P I write 9, that is the price of output. So 9 9 into Q minus price of labor is 1, so we write only L, minus price of capital is 4, so I write PK is 4 times K. This is the profit function. Let us further expand this. Now we know Q is this very term. Okay, if I write Q is equal to, can I write it like this, L plus K divided by Lk, and it will be equal to L upon Lk plus K upon Lk. Okay, so I am just expanding this basic rules of addition when we have the numbers in fractional forms or the variables in fractional forms. So here L and L gets cancelled, K and K gets cancelled, we get 1 upon K plus 1 upon L. Okay, so we have profit will be equal to, so we have 9 in place of Q, sorry, we have also 12 here, sorry for this mistake, so I have 12 minus this stuff, so we have 9 times 12 minus, okay, then we have, so this stuff I solved it like this, it became 1 upon K. So since we have minus here, so it will also become minus into pluses, minus 1 upon L. Then we have minus L, this minus L, then minus 4K. Okay, I hope I am making myself clear here. What I have done here, I have simply expanded this in this form. So actually we were having 12 minus this setup. Okay, so this minus is to each of this term, so it becomes here 12 minus this stuff, so it will become 12 minus 1 upon K minus 1 upon L. I forgot to mention the 12 in the production function. So this is our 12 minus 1 upon k minus 1 upon L, and we multiply it by the price of output, that is 9. This is our profit function. Okay. Now what is the first condition for profit maximization? Since we have two variables here, I will write a first order condition for profit maximization. Profit maximization requires that the marginal profit with respect to k and L should be equal to 0. That is, the derivative of profit function, or let me write it here, I have the space, the derivative of profit function with respect to, so I don't have the space here, the derivative of profit function with respect to L, it should be equal to 0, and the derivative of profit function with respect to k, it should also be equal to 0. So we need to find out these two derivatives. These are the partial derivatives here, obviously. So can I rewrite it like this? So let me rewrite the profit function to expand it. So profit is equal to, profit is equal to, so multiply this 12, so 9 2s are 18, 9 1s are 9, target 10, we have 108 minus 9. I am multiplying this 9 to each of these terms, then we have minus 9 upon L, then we have minus L minus 4k. This is our profit function. Okay, now we need to take the derivative with respect to labor first, that is the derivative of profit function with respect to labor, it should be equal to 0. Let's take the derivative. Derivative of a constant is 0, derivative of k, sorry, derivative of the second term will be also equal to 0 because we are taking the partial with respect to L. Derivative of 9 upon L, it will be equal to, so the derivative of 1 upon L is equal to, so we can write it like this, L raised power minus 1. If I transpose denominator to numerator, exponent sign changes. Now the derivative of L raised power minus 1 is equal to, exponent becomes coefficient by power function rule, we have minus 1, L raised power, and exponent is subtracted by 1. So we get minus 1 into L raised power minus 2. Can we write it like this? Minus 1 upon L square. If I transpose this back to the denominator, exponent sign will change. Okay, since we have this minus also here, so we will get so the derivative of 1 upon L is minus 1 upon L square. Since we have minus also here, so minus into minus will become plus, so we will get 9 upon L square. Similarly, the derivative of L in this third term or fourth term is 1, and we set it equal to 0, solving, so we will get 9 upon L square is equal to 1, which implies L square is equal to 9, or L will be equal to under root 9. If I transpose this square, it will become under root, so L will be equal to 3. So units of labor employed will be equal to 3 for at profit maximization. Similarly, we need to find out the derivative of the profit function with respect to k. Okay, this time we take the partials with respect to k. Now derivative of a constant is 0, derivative of 9 upon k will be equal to, so we have minus also here, so minus into minus will become plus, as I have explained it here. So it becomes 9 upon k square. Derivative of k in the last term is 4, so we are left with, derivative of k is 1, so we are left with minus 4, and we set it equal to 0. That means the partial derivative with respect to capital. Okay, solving it, so we have 9, or let us write it with another color to highlight this. So we have 9 upon k square is equal to 4, or we will get cross multiplying, we get 4 times k square is equal to 9, or k square is equal to 9 upon 4, or k will be equal to, it will become under root of 9 upon 4, so k will be equal to 3 square upon 2 square, so k will be equal to under root of 3 upon 2 whole square. Square root gets cancelled, so k will be equal to 3 upon 2. That means the number of capital units employed will be equal to 3 upon 2. So we got L is equal to 3, K is equal to 3 upon 2. Then what will be the maximum profit? So simply plug the value of L and K. We need to plug the L and K into the profit function. So this is our profit function, or let's put it in this equation. So our maximum profit will be equal to, so profit will be equal to, so we have 108 minus 9 upon K. K is 3 upon 2. Okay, so 9 upon 3 upon 2. Then we have minus 9 upon L is 3 minus, then we have L again 3 minus 4, the value of K is 3 upon 2, 3 upon 2. Let us solve this. So we have 108 minus, so we have 9 upon 9 upon 3 upon 2. So it will become 9 into 1 into transposing, it will get reciprocated and multiplied. 3 ones are 3 twos are, so sorry, 3 ones are 3 threes are 9. So we get 3 twos are 6. So this becomes 6. So we have 6 minus, so 9 upon 3 is 3. Then we have minus 3. So 2 ones are 2, twos are 4. So it also becomes 6 here. So maximum profit will be equal to, so Kshetragya now the other, we get 108 minus 18, which comes out to be 0. So now, so the maximum profit will be equal to 90. Okay, so the correct option should be this option.